the DRAM stands for Dynamic Random Access Memory. The DRAM includes a MOSFET transistor and a big capacitor. Now, the reason for big capacitor is to store the information using the charge. The charge between inside and outside the capacitor will form an electric field. The DRAM with electric field will have the information 1. Without the electric field, we will have information 0. So storage or not storage information will stand for storage or not storage electric field, storage or not storage the electric charge, and therefore 1 and 0. When we storage the information, they'll have a word line and bit line. Now we look at this picture. The word line is to say which pixel we want to pick is the orange part on the graph. The orange part stands for the gate to affect the channel below. Word line is a control gate. We tell the DRAM which bit we want. And the bit line is a connection. We take the information out. So the word line connect to the control gate in this picture is the orange part, which will create an electric field to affect the channel below. When the channel is open, the charge storage in the big capacitor will flow out to the green part, and green part will take the information out as the bit line. So that's the word line and the bit line. The word line and bit line all stand for all the memory system we used, including the DRAM and the flash memory. Even though the DRAM takes a very, very long trench or hole to make it, it occupies a very large Z direction. However, we can still stack one DRAM atop another DRAM, make a 3D DRAM to make more memory on the same dice area. And that will be it for the DRAM section. Hello everyone, this is Power Lin. Now we're going to talk about semiconductor memory now. Now there are 3 types of major semiconductor memory. One is the SRAM, which looks like the logic circuit. MOSFET, FET gate-around. It can be made from those gate-around the logic circuit. Then we have the DRAM, Dynamic Random Access Memory. Now this part, this piece. So, and then we have the third one is called a flash memory. Now for all the memory, there are 2 kinds of line. One is the word line. Word line connect to the gate. So the word line determines which cell you want to access. For example, if I open this word line, this orange word line, then the information from this cell will flow to the bit line. If I open this word line, the information of this cell will flow to the bit line. So the bit can be 0 or 1, depending on what's storage in the cell. Okay, so this is the word line and this is the bit line. And for the flash memory, this called a gate, this is called a floating gate. It stores the information in the floating gate. So if I close the gate, then no matter information gate or 1 or 0, there will be no current flow through. If I open the gate, if the information storage in the floating gate is 1, then the current will flow through. So the gate connects to word line as well, and the information storage in the bit will flow out to the bit line. The information storage in the floating gate will flow out. A few things to mention about the DRAM. So you can see the DRAM for each cell, it contains 1 metal oxide semiconductor, one MOS. And you have another big capacitor. So how do you squeeze a big capacitor into a limited die cell? Okay. So that way you just make it very, very strong, very, very long in this direction. So you can make a big capacitor. Then if I have a storage information or a storage charge in the big capacitor, when I turn on the word line, which is located here, the charge will flow out to the bit line. So then will be 1. And if I have no information storage in the big capacitor, when I turn on the word, there will be no charge flow out to the bit line, so there will be 0. So 1 or 0 depends on the charge is stored in the capacitor or not. Another thing is the capacitor, this capacitor is connected to the bit line through a semiconductor channel. Even though the channel is closed, there is still some leaking current, thermal leaking current flows through. So the DRAM cannot store in the information for a very long time. Okay. It's in a matter of a microsecond to millisecond for the DRAM to lose the information. So you need to recharge the DRAM every few milliseconds. Now, if you look at the DRAM here, we can see the capacitor here, and MOS is right next to it. So if you look from the top, you can see from the die, from upside down, you can see in the die, the MOS occupies its own space. Capacitor occupies its own space. This is called 2-dimension DRAM. Now when it comes to 3-dimension, I will stack the MOS atop the capacitor. So it's going to look like this. Okay. Here. So here's for here to see from the top. Okay. And this is the ground. So see from the top. And this is the ground part. So if I take it apart, you can see I have a capacitor. Now here. The yellow line here stands for the word line. Why it called the word? Why it called the word? Okay. Because if I turn the word on, this information will take out, this information will take out. If I turn this word on, this information will take out, this information will take out. So you turn on a word, not only one bit of word together. Okay. And this is the word line. And when you turn on, the capacitor's information will flow from the capacitor part to the here. This one called the word line. So the green one, the yellow one is word line. Turn on the mouse here, MOS FET here, and the capacitor works as a source, flow to the drain, which is a bit line. Okay. So, for example, if I turn this word line on, then the word information flow out from this bit line will be this bit, and the information flow out from this bit line will be this bit. And if I turn on this word line, the information flow from this bit line will be this bit, and the information flow from this bit line will be this bit. So the word line control the gate to allow the information to choose the information which one to flow out. Okay. And when the capacitor, then the capacitor will be, this is called 3D because the capacitor is right atop the MOS FET, the word line structure. So if I take it apart, what's the capacitor look like? We all like first look from the side for a few seconds. You can see you have the ground line inside here, Then outside ground line is a insulated part, and this one is a titanium nitride conductor. And then the outside conductor and inside conductor, between them has an insulated layer, which allows electric field to form when you store information in the solar capacitor. Positive one is this one, negative one is this one. Allow the information to be stored. So, and I take it apart, you can see from inside, the ground all the way down, ground all the way down, and just like in. So put on the ground from the center for a few seconds. The ground from the center, and this ground. Okay, all the ground connect together since they are used to supply the opposite charge compared to the charge you need to store here. Okay. So, if I take apart, this is a capacitor outside capacitor. Sorry. Okay, Wait a second. The capacitor outside, capacitor inside. Okay, capacitor inside connect to the ground line. And if I take apart one by one, if I only take apart the insulated one out away, then there'll be this one. Okay. And there'll be the titanium nitride connect like this. Okay. And of course, this one take the insulator out. If I take the insulator out in and put the titanium nitride inside titanium nitride away, it's going to look like this. Going to look like this. Okay. So titanium nitride, insulator material, titanium nitride away in this picture. In titanium nitride take away here, and here is the ground plate, ground. Okay. Titanium nitride, and then the insulator, then finally outside insulator. So that's the way. This is called a 3-dimension. They put the word 3-dimension because the MOS FET, the gate, is right stack on the same Z direction, on the same XY position, which is stack up in the Z direction of the capacitor. Okay, that's why it's called a 3D DRAM, 3-dimension DRAM. So in this the 2-dimension direction, that's a chip direction. This one down is the chip direction, Then you have the MOS FET. Then so this is the bit line, borderline capacitor. Okay. Normally the capacitor much longer than this one. About normally the ratio of the width compared to the height, the width compared to the height is about 1 to 10, much longer. For the because the longer the capacitor, the larger the capacitor. And this one is called a 3-dimension DRAM. Okay, the 3D DRAM is stack the capacitor atop the MOS FET. Oh. Okay, the 3D DRAM you stack the capacitor atop the MOS FET. Now for the HBM, high bandwidth memory, you stack a layer of MOS FET with capacitor atop another layer of MOS FET with capacitor. So it looks like this. Okay. So you see the So you see the MOS FET, which is the word line, okay, and of course the bit line come out here, and here's the MOS FET word line, bit line come out here, and here is the MOS FET capacitor. So, for example, if I turn on the word line, this word line, okay, then the capacitor, this capacitor information will go through and go on from this bit line. This capacitor, this bit line, this capacitor, this bit line, this capacitor, this bit line. Okay. And again, on top of here, the same thing. If I turn on the word line here, this capacitor through this bit line, this capacitor, this bit line, this capacitor, this bit line, this capacitor, this bit line. And about which the control of the word and the bit will all come out. The information will all come out. So this is a major chip. This is the chip control the word and the bit. So this one tell okay, which this chip here tell the this chip tell which word line to turn on and pick up information from the bit line from here. And this is for one layer. Now between the layer, so here you see lots of insulator. Between layer to another layer, okay, the another thing called a TSV to feed the information and the ground from one layer to another layer
all the way down, so you can see the color via feed through via the narrower for tunneling. So this one is the ground feed through, and this one is the information for the this is a chip to control the word line and the bit line in one layer. This is another chip control the word line and bit line in one layer, and the feed through between the layer. So lots of this MOSFET capacitor, layer by layer, stack up. Okay, and then I got this called a high bandwidth memory, which is actually the stacking up of many 3D dynamic random access memory. If you have any question or comment about this course, you are welcome to contact me in the following line. Thank you for listening.